Hey, good people, welcome back. This is Arthur Morris. Hope that all is well with you today. In this video, we are going to look at graphs of logarithmic functions. Now, the graphs of logarithmic functions are the inverse of the graphs of exponential functions. So we know that 2 to the x, uh, the graph of 2 to the x is the inverse of the graph of log base 2 of x. What does inverse mean? Well, if I have the points as shown in the graph of the function 2 to the power of x, negative 2, 1/4 here, 1, negative 1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8, then the ordered pair for the log base 2 of x will just be flipped. So the x's and y's will be flipped. So instead of negative 2, 1/4, it will be 1/4, negative 2, 1/2, negative 1. Now you can see that this logarithmic graph here in red has a vertical asymptote instead of a horizontal asymptote. And the vertical asymptote is the line of the y-axis, or x equals 0. So the vertical asymptote here of the log base 2 of x with no translations is simply x equals 0. Our domain, remember, that runs along the x-axis. See how far the graph extends from left to right along the x-axis. So our domain would go from 0 to positive infinity. 0 to infinity. Range, remember, that means from bottom to top. Our range for that logarithmic function would be from negative infinity to positive infinity. So there's a vertical asymptote at x equals 0. The x-intercept is 1 here. The domain is the positive value, so 0 to infinity. And the range would be negative infinity to positive infinity. So just the opposite of what we had, the inverse of what we had with the exponential functions. And you can see that same information here on this page. And you can see that this is reflective across the graph line y equals x. Okay, so let's look at this problem here. It says to graph f of x equals 5 to the power of x and g of x equals 5 base 5 of x, log base 5 of x in the same rectangular coordinate system. So if I make a table for f of x, and plug some values in for x, negative 1, 0, and 1, then 5 to the power of negative 1, use our reciprocal rule, is 1/5. 5 to the power of 0, anything raised to the power of 0 is 1. And 5 to the first power is 5. Plotting those points, negative 1, 1/5, 0 and 1, and 1 and 5, I see that that could be either graph, I'll call this A, B, or D, the first, second, or the fourth graph. That would be in green there. Now, g of x, since this is log base 5 of x, then I know that this is the inverse of that original graph there, that exponential graph. So I could just flip-flop the ordered pairs. So 1/5, negative 1, 1, 0, and 5, 1. So if I look carefully, I'll see that graph number 2 provides both those functions, the graphs of both of those functions. Again, with the logarithmic function, um, we have the vertical asymptote of x equals 0, the y-axis, you can see here. We also have a domain of 0 to infinity, and a range of negative infinity to positive infinity. Okay, now this is the same graph as the one on the previous page, with the exception of this x plus 1. That means we have a transformation or a translation here. And remember that plus 1 within the function of x means that we have a horizontal translation. And since it's plus 1, that means we're going to move to the left one place. So my previous table for log base 5 of x, we had negative 1/5, 1 and 0, and then 5 and 1. All right, so since we are shifting to the left one place, that means that our x values are decreasing by 1. So for g of x, I don't have to do any calculating. So far as plugging in, I just need to subtract 1 from each one of my x values. So my y values remain the same. Uh, we had not negative 1/5, sorry. We had positive 1/5 and 1/5 minus 1. 1/5 minus 1 would be 1 over 5 minus 5 over 5, which would be negative 4 over 5. Subtract 1 from this second value here. 1 minus 1 is 0. And again, I'm doing this because I had a transformation here horizontally to the left one place. And then 5 minus 1 is 4. So negative 4/5 and 1, or negative 1. So here, 0, 0, my x-intercept, and then 4, 1 here. Now what you will see is that in this time, everything shifts to the left one. So my asymptote shifts to the left one. So my asymptote is the graph of the line x equals negative 1. My domain shifts to the left 1. So now it's negative 1 to infinity. And then my range, it stays the same, negative infinity to positive infinity. Alrighty, good people. I hope you found this video to be helpful. I will see you on the next one. Thank you.